Okay guys, today we're going to take notes on facilitated diffusion and active transport. So you should title your notes, Facilitated Diffusion and Active Transport. And we're looking at how they're unique, and really we're going to compare them to the other types of transport, osmosis, and diffusion that we've learned. So make sure you have your essential question before you move on. So remember, the lipid bilayer or cell membrane will allow most small molecules to diffuse, which is going from high to low concentration, but not everything can get through. Large molecules can't get through, charged molecules can't get through. So we're going to talk about how the cell takes care of those things, because you need glucose, you need amino acids, you need that stuff to survive. So how do you get them into your cell? I want you to briefly answer this question, just what you think in your notes, and then raise your hand so I can come check it. You get things into your cell through what we call transport proteins. So that word transport needs to be in there. They make pathways or channels to let large particles through. Okay, so these are the proteins. We call them protein channels. I want you to draw this diagram in your notes, and make sure you raise your hand so I can check it when you're done. Okay, facilitated diffusion is what we call the transport through those proteins of molecules across a membrane. It is still high to low, and it takes no energy from the cell. This is just a cute picture of facilitated diffusion, because sodium, anyway, it's a joke. But protein channels, we're going to go from high to low, but they have to go through the protein channel. So my arrow, it would be going this direction. Nothing for you to write here, just making sure you see that. Now remember, going from high to low doesn't take energy from the cell. It's rolling a ball downhill. The hill doesn't have to do any work. If the hill wanted to try and get this ball back up, I mean, one, that would be a miracle of physics, but two, it would take energy, okay? So going with the flow doesn't take energy. It's easy to walk with a crowd of people. It's hard to walk against a crowd of people. Okay, but if your cell needs to go against the flow, if it needs to go from a low to high concentration, it can. It's just called active transport. It has to use energy to go against the concentration gradient. If you push a ball up the hill, that takes some energy from you. So it takes the cell energy to go low to high. It still goes through a protein channel. Okay, and that molecule of energy is called ATP. So ATP is energy for the cell. It's made in the mitochondria. Make sure you write mitochondria down. Remember, the mitochondria is the powerhouse of the cell. It's what gives you energy. The energy is ATP. Okay, so now we're going to summarize everything and make sure you kind of got everything in your head. So we're going to talk about this chart together. So in simple diffusion, is a transport protein used? No. No. And things get to move from a high to low concentration? That doesn't take energy. That is passive transport. It doesn't take energy from the cell. For osmosis with water, no transport protein. You're still going high to low. No energy, passive transport. It's diffusion of water. Facilitated diffusion, guess what? Still diffusion, but you use a protein channel, okay? You use a protein channel, so things have to go through the protein channel. And in active transport, active energy, you use the protein channel, but this time you're going from low to high. So you need that ATP, that is active. So that's a summary of everything we've talked about for the past 2 weeks, and that should help you with your test on Thursday. Okay, in the summary section of your notes, I want you to answer these 3 questions. You just need the answer, not the question. Then raise your hand for me to check it and give you a grade.